Here is question number 26. For a transistor in active region, you are having four options. The base region must be very thick and highly doped. That is not correct. Emitter have the maximum doping. Both emitter base junction as well as collector base junction are forward bias. Okay. Base emitter and collector region should have similar size and doping concentration. Okay. The emitter base junction is forward bias and base collector junction is reverse biased. So first of all, I want to tell you the regions of working of transistor. Transistor has three regions to operate. And they are, the first region is active. The second region is saturation. And the third region is cutoff. The transistor works differently in these three regions. In active region, the emitter base junction must be forward biased and collector base junction must be reverse biased. In case of saturation region of transistor, both junction will be forward biased. On the other hand, in case of cutoff region of transistor, both junction should be reverse biased. So in cutoff, since both junctions are reverse biased, so this is off condition of the transistor, or you can say it works like open switch. In cutoff region, transistor works like open switch. In saturation region, both junction forward bias. So in saturation region, transistor works as closed switch or on condition you can call. Closed switch or on condition you can call. On the other hand, in case of active region, transistor behaves as an amplifier. So here it is used as an amplifier in active region. So after getting this concept, we can say that we will have to go with option number 4, which is absolutely correct. The emitter base junction is forward bias and base collector junction is reverse bias if active region is told to you. Now let us proceed to the next question, that is question number 27. So here is question number 27. The real-time variation of input signal A and B are shown in figure. If the input are fed into NOR gate, then select the correct output signal. We can solve such kind of questions with the help of truth table. So two inputs are there, A and B. Output is in the form of NOR gate. So first let's try OR output, and then ultimately Y equals A or B complement. Input A, that is low 0 high 1, low 0 high 1. So input of A is 0 1 0 1, and for B it is 0 1 0 0. So 0 1 0 0. OR gate produces output 1 if any of the input is high. So 0, both are high, so output 1. 0, input A is high, so 1. Now NOR is the complement of OR, so that's why we will get 1 here, 0 here, 1 here, 0 here. So output is 1 0 1 0. Now let us check the options. 1 1 0 1 for option number 1, so it is wrong. Option number 2, 0 1 0 1, again it is wrong. Option number 3, 0 1 1 1, again it is not matching with our final output, so this is wrong. Option number 4, 1 0 1 0. So after looking at the option number 4, we can say that it is absolutely correct. So that's why we'll go with option number 4. Now let us proceed to the next question, that is question number 28. Here is question number 28. A p-type semiconductor is, you are having 4 options: positively charged, electrically neutral, negatively charged, positively or negatively charged depending upon amount of the impurity. Now we know very well that all type of semiconductors are electrically neutral, so that's why we will go with option number 2. Since we know very well that all types of semiconductors are electrically neutral, therefore option 2 will be correct. Your p-type semiconductor must also electrically neutral. We'll go with option number 2. Now let us proceed to the next question, that is question number 29. Here is question number 29. A point source of light is placed at a distance of 2 meters from a photocell and cutoff potential is found to be V0. If the distance between point source and photocell is halved, then cutoff potential will be what? We know very well that the cutoff potential depends only upon the frequency of incident light. And this frequency is independent of distance. So that's why we can say that the cutoff potential will not be depend upon the distance. So let's write, since cutoff potential depends on frequency of incident light which is means frequency independent of distance between source and photocell. That's why therefore we can say that cutoff potential is independent of distance. So therefore here cutoff potential will be same. So that's why we'll go with option number 1 only, which is absolutely correct. Now let us move on to the next question, that is question number 30. Here is question number 30. A photon of energy E0 falls normally on a perfectly absorbing surface. The momentum transferred to the surface will be what? Now, we know very well that the energy associated with photon is given by hc by lambda, and according to de Broglie relation, we know that lambda is h by p, or h by lambda we can write p directly. So in the given energy equation, E0 can be written in terms of momentum, that is p times c. So the momentum of photon, that is initial momentum, will be E0 divided by c. So this will be the initial momentum of photon. Finally, it is absorbed to the perfectly absorbing surface. So the final momentum will be 0, and therefore we can write the change in momentum magnitude is what? P final minus P initial, and which comes ultimately E0 divided by C. And after looking at the options, we can say that option number 2 is absolutely correct. We'll go with option number 2. Now let us proceed to the next question, that is question number 31.